3.1, using models to multiply fractions. So grade 8s. Yeah, we're going to use a whole bunch of models to multiply these fractions. Now, there is a frustrating part when we get to the very end for multiplying fractions. I actually believe that multiplying fractions with numbers is exquisitely easy. It's easier than adding fractions when you're only using numbers. The thing is we get to that estimation piece. A lot of you get your quizzes back and you notice, oh, I didn't estimate at the end, and I ended up getting questions wrong that I knew how to get right. Well, that's why we go through these models, so that we can visualize what the actual multiplication of fractions is. So first, let's look back. How many ways can you find this sum? 2 plus 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 2. Now, when you were in grade 2, what you did is you went 2 plus 2 is 4 plus 2 is plus 2 is. Okay. Then in grade 3, you did it different. What did you do in grade 3?
Some songs.
What's that?
Some songs to memorize it.
Yeah. Maybe some songs. But then you would go like this. You go 1, 2, 3, 4, 5, 6, 7, 8, 9 twos. What's 9 twos?
18.
How did you do that? Did you go 2? Did you go 2, 4, 6, 8, 10, 12, 14, 16, 18?
Well, some.
No, you just did 2 times 9. So you learned that that multiplication is like multiple addition. So that's where we're going to start. Now, these characters are really small. I expect that you guys out there in YouTube land should have a copy of this textbook. If you don't have a copy of this textbook, you're probably not in our class. Get out, creeper. Or you're just getting an educational exercise. Then good for you! We can find a meaning for 1/5 plus 1/5 plus 1/5 plus 1/5. And that equals 4/5. But there's a few ways that we can look at it. And we're going to move pretty quick. So be very, very mindful of this. Here we have 1/5. Plus 1/5, plus 1/5, plus 1/5 is the answer. 4/5, yeah, you add them all up. Like if I took this piece and put it there, and this piece and put it there, and this piece and put it there, I would have 4 out of 5 filled. So 1/5, we're just doing that repeated addition. So the first part, easy peasy, we can just think of that repeated addition. Similarly, 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. Wait a minute, that's 1, 2, 3, 4, 5, 6, 7 times 3/4. What's 7 times 3?
21.
21. And then we got
Which
over the
is
4, 21 over 4. Can you hit pause on our video for just a moment? We'll check on the boards. A little pause icon right on the screen. All right, welcome back, grade 8s. All right, so the next one, we can use a number line divided into fourths to show something. Now this is where it has 7 times 3/4. That is the same one. Now I'm not going to draw it because you've got it right in your textbook, but I want to make sure that all eyes are up at this point so you can see this. It says 7 3/4, and what we did first is we had done it previously where we just looked at 3/4, and then we saw that there was 7 3s, and we had counted them up. 7 times 3 would be 21 over 1/4. But now we've got a number line, and we're using the number line to jump. So what we're saying is how many 3/4, or how many quarters if we jump 3/4 7 times. So here we have 7 jumps. 1, 2, 3, 4, 5, 6, 7. And what we did is we jumped 3/4 each time. So let's go 3/4, 1 1/2, 2 1/4, 3. But we did it 7 times and saw where we arrived at. Now, if you look at the floor here, if you imagine that each of these tiles was 1/4 of 1. So each of these tiles is 1/4, and I start going 3, and I'm going to do 7 times. So here's my starting tile. I've got 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps, 7 jumps, and then I count how many tiles it's going to be. That's going to be 21 tiles, or 21 quarters. And that's what we did here. We jumped 3 tiles, or 3/4, 3 more tiles, and we did that 7 times. 7 times 3/4, and when we got to the end, it was at 21 quarters. All right, next one. I'm just gonna, can you hand me my mouse there? It's just beside something. Thank you. Then I can scroll down a little bit. This is another visual way that we can look at 3/4 times 7. And then we're going to pause the video and we're going to get a couple samples of the number lines and this piece here. This is where they did 1, 2, 3/4 of 1 times 1, 2, 3, 4, 5, 6, 7. And when they did that, they could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 16, 17, 18, 19, 20, 21 quarters. So now we're going to pause the video. We're going to take a look at a number line. And what we're going to do, and for those of you who are watching the video, you may want to pause at this point. We're going to go, here we'll do 5 times 3/4 for your example. So it's very similar to this. Or you know what, actually we'll change this. We'll do it 9 times 1/2. Okay, I'd like you to represent 9 times 1/2. So please pause. All right, thank you out there. So we've got a number line, and first we estimated, we figured that it'd be a little less than 5, and then we made a number line that had 5, and we put our half marks. So we want 9 halves. So this is a half. We want 9 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now you can see what our answer is. It looks like 4.5 is our answer. Then we did it like the block method here. We had 1/2 right there, but we wanted 9 halves. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, if I were to reposition these, 2 of these is 1, so that's half 1, half 2, half 3, half 4.5. We get to our 4.5, and that is just like our 7 times 3/4 examples there. Let's look at another way that we can do things. Here it says, once again, there's the number line, 21 times 2/3. So what they did is 2/3, they jumped it 21 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And you see where you get to?
It should be 21.
But let's look at an easier way to do that. Let's look at it with counters. It says 21 times 2/3. Observe my counters. I have 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It says 2/3 times 21. 2/3 times 21. What is a third of 21?
7.
7. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, did I miscount? There we go. I miscounted these ones. I had 22. There we go. You see that? Do I have my thirds?
Yes.
Okay, it says 2/3 times 21. 2/3 times 21. Is this 21? Okay. Is this 2/3 of 21?
Yeah.
How many counters? Watch. What is 2/3 of 21? What's 2/3 of 21?
14.
14. So 2/3 times 21? 14. Take a look at the number line up top. When you jump 21 times 2/3, what do you end up at? 42/3 or
14.
14. This time we were happy enough to land on a whole number. Now, why is this visual good? If I were to say 2/3 times 21, you should be able to estimate roughly 2/3 of 21. So for example, if I said, what is 3/5 times 10? 3/5 times 10. I could draw a number line and I could put 3/5 and jump 3/5 10 times. I could also do these and I could draw 3 out of 5, 3 out of 5, 3 out of 5, 10 times. But now you can probably think of a shortcut. Can anyone tell me what 3/5 times 10 is?
That's like.
What's 1/5 of 10?
1/5 of 10
6.
is 2.
1/5 is 2.
I was gonna say 6
2/5
times
is 4.
10.
3/5 is 6. Absolutely. Let's do it on our blocks. 3/5 times 10. All right, let's get 10 blocks. I got 2, 4, 6, 8, 10 blocks. And it says 3/5. Okay, let's split this into fifths. I've got 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I now have 5/5 of 10. How much? Well, can you see all of those? How much is 3/5 of 10? 6. Is this not the best model of the three?
Yes.
You know why we can't always use it? If you look back on the board by what we did, could we have done that for 9/2?
No.
No, we couldn't have. That's why we had a few different models. But I know that if I make 9/2, what's half of 9?
4.5.
4.5. So you've got a couple different ways that you can think about it. All right, let's take a look back at the assignment. We are almost done, ladies and gentlemen. We've gone through most of the models. And there's your final one. Here it says an office building with 4 floors is rented out 3/5 of each floor. This is where you can use multiple models. But this is one final way to do it. They said 3/5 of each floor. What they're saying is imagine, close.